Alright, so in this particular video we're going to look at active transport. Now we've already looked at diffusion, and we've learned in diffusion that you can have passive transport going from high concentration to low concentration across a membrane. That's going through the phospholipids, and you can have facilitated transport, still going through the membrane, but this time going through the proteins, either a protein channel or a protein carrier. It's passive or diffusion, so it's still high concentration of the solute, which is dissolved in the water, to the low concentration side until equilibrium is reached. Now I want to look at active transport. And active, well, the name active suggests that you need an energy input, and that is exactly the case. Active transport does the opposite to what passive transport does. So I'm going to keep this very short because it's actually a very simple concept. I'm not going to get into secondary transport in this particular talk. If you want to know more about that when you cover it in the PowerPoint, then please get in touch with me and I can explain the different aspects of secondary transport, from primary to secondary, and also antiport, etc., and co-transport. So, in active transport, this time the solute's going against the natural concentration gradient. So it's going from low concentration to high concentration. In order to basically do that, it needs an input of energy, and in the cell an input of energy is ATP, so we need to use ATP to make it happen. So it requires energy, and it also requires a specialist protein carrier, and these protein carriers are referred to as pumps, because they are literally pumping the solute across the membrane using energy in exactly the same way as, say, your sump pump in your basement. You switch the electricity on, it's taking water from where you don't want it but is in low concentration and pumping it out into a higher concentrated water area, but it's in the drainage ditch. So the diagram here is again showing us our cell membrane. Here's our phospholipids, here's our integral protein. This protein, however, will only push a hydrogen across and through it by the addition of adenosine triphosphate. And that adenosine triphosphate, once it phosphorylates, becomes adenosine diphosphate. So the phosphate stays here, so inorganic phosphate, and then you're down to 2 phosphates on that molecule instead of 3 there. But that releases energy, and that causes the change in this protein. Remember, in the facilitated protein, the binding caused the change. In this particular environment, the hydrogen can get on there, but until you expend the energy of the ATP, this will not open on the other side and allow the hydrogen to go through. So you can see that the concentration of hydrogen here is quite low, and the concentration on the other side is quite high. So it's pushing into a higher concentrated area, which would normally equilibrate this way. I mean, if you've ever been traveling, etc., and you can take, these days you can take like 1 free checked bag instead of the 2 that you used to be able to. So people try very hard now to get all their stuff in 1 bag. And you know yourself how difficult a suitcase is to deal with when you've got, it's basically full and you're still trying to put in 2 sweaters, as you would say here, 3 t-shirts and a few other things, and you're basically shoving it in. So your clothes are going from a low concentration to a high concentration in the suitcase, and you're putting in a lot of energy to actually force them in and get that zipper closed. Same idea here. Because this is moving hydrogen ions, and a hydrogen ion, if you remember, a hydrogen atom is just a proton and an electron. Once you've ionized it, you've taken away the electrons, so you're just left with a proton. So this particular protein is called a proton pump, because that's what it's doing. It's pushing hydrogen ions, which are protons, and pumping them across into the higher concentration. So when you're thinking about active transport, you're thinking about 2 things really. Input of energy, going from low concentration to high concentration using a pump. So I think if you count that again, that you'll find it would be 3. That's all I wanted to say about active transport.